Hello, everyone, and welcome to the VIP experience at the AM Industry Summit, powered by ASME, Collective Intelligence for Additive Manufacturing, featuring AM Energy and AM Aerospace. I'm Debbie Holton. I'm the Managing Director of Industry Events for ASME, and on behalf of our over 100,000 members around the world and the entire ASME organization, thanks for being here. I'm really glad you decided to join us. ASME is building a community around additive manufacturing, and we're working together with industry to really move technology forward. And we love to bring folks together just like we are tonight. And we really appreciate you all being here and taking your time to spend at this new VIP experience, which is really all about networking and getting together. But of course, we couldn't help but bring a couple of rock star speakers on and really start your mind thinking about all the possibilities around additive manufacturing. You know, at ASME, we've been convening working groups and advisors around key industry topics, including COVID response and supply chain, creating standards, of course. We're a standards organization for model-based enterprise, product definition, CT and bioprinting, metal and polymer AM. We're inspiring engineering students through our E-Fests, which are our engineering festivals, and our additive manufacturing competitions. ASME is empowering the next generation of AM engineers through the ASME Foundation as well. And we are in the midst of a capital campaign to really drive diversity and inclusion in the engineering community. We're driving workforce development via our innovative design for additive manufacturing courses, and you can access all kinds of resources through our webinars, journals, and of course our AM Medical Year in Review report, which just came out a couple months ago, still very fresh off the press, and our new AM e-newsletter will keep you up to date. And we're so glad you're here at this event today with us. As you know, additive manufacturing provides all kinds of new capabilities and tools that enable us to transform manufacturing and unlock new capabilities. And so join me in thanking GE Additive, who is our presenting sponsor for today, and also to Link3D, who is our digital sponsor, who is also helping us here on the Remo platform. After this wonderful session we'll have right now, Janet Carr from Link3D will come on and give you a few tips on how to make the most out of this wonderful interactive platform called Remo. And now I'm really pleased to welcome Josh Mook, who is an innovation executive at GE Additive. His presentation is titled Building a World That Works, How the Landscape of Manufacturing is Changing, and Don't We Know It? that don't you know it is my part, not his. But as the innovation leader at GE Additive, he leads a cross-functional team to accelerate additive design and manufacturing innovation and promotes disruption and global innovation. Josh has been flying airplanes since before he could even drive a car, and he began his career at GE Aviation, where he showed a penchant for creative problem solving. And so when you show an ability like that at a company like GE, you get a lot of cool things to do. And so when GE asked him to join the team that was trying to 3D print a fuel nozzle for a new jet engine, which we all know very well now, he leapt at the opportunity. And even at that point, he kind of lacked experience with the fuel injection and the 3D printing. He used a phrase which I love, which kind of underlines my approach as well, which is the way to motivate me is to tell me something can't be done. And that's what Josh said. He brings a lot of passion and experience in application design, systems development, program leadership, and in driving change. And his first big success came when he found a clever way to fix a blade durability problem in a jet engine, high pressure compressor. And his solution was so good that it took off and found applications inside machines made by other divisions, both GE Power and GE Oil and Gas, which is now Baker Hughes. But you can see the connections too between aerospace and energy and why we're all here together today. So I would like to welcome Josh Mook. Let's all welcome him to the stage. Josh.
Thanks, Debbie. Like Debbie said, my name is Josh Mook, and I'm coming to you today from Cincinnati, Ohio, and really excited to walk through some of the applications and some of what's new here in the additive world, and kind of get into some details. We'll keep it light. I know everybody's excited to get and do some networking and ask questions and things like that. So, but I first thought I would do maybe give an introduction to myself and get us kicked off here with a little bit of background about me and sort of how I got to where I am now. So we'll watch that, and then we'll come back and talk some applications. All right, so that was a little introduction about myself, and I noticed before the event, somebody had taken a look at, assumed that was a like a stock or rent a family, but no, actually that was my real family, and you know, a little bit of story about my background. So let me share my screen here, and we're going to get into you know, really digging into some applications and some state of the art of where additive is today. You know, like I say in my title, we're really focused here at GE on building a world that works. And I think the landscape of industrial manufacturing is finally changing in a meaningful way. I mean, I feel like for a decade we've sort of been alluding to this change that's coming, but it's here on top of us now. And I think it's really apparent, and I want to walk through some examples and some case studies of what we see going on. But you know, before we get there, I just want to say, I don't know how many of you feel like this sometimes, but I spend a lot of time talking to customers and talking to, you know, potential users. And you know, as you maybe saw with my background, my passion area is really centered around applications, and how are we going to change the way applications look forever? How are we going to change the way jet engines are? How are we going to change, you know, aviation or energy applications? How are we going to change healthcare? And you know, 8 times out of 10, at least in the previous years, when we go talk to folks around how are you using additive or why are you adopting additive, this is sort of the response I get is that we're chasing it really hard. We know we're chasing it because everybody else is chasing it, and we think it's going to be really important. But I think, you know, until I'll say in the last couple years, you really didn't see those really detailed application trade studies going on in those and starting to design products for additive. And of course, that is extremely important. And I want to talk through some of those instances here today. You know, I think the other answer that I would often get was, well, we want to use additive to make prototypes. And I think prototypes are great. I have a saying, it's literally on the wall in my office, that says a prototype is worth 1,000 meetings. And I believe that with all my heart. And so we prototype a lot and we iterate a lot, and we're always focusing on, you know, how can we move forward, both in machines and applications and materials, et cetera. But I have to say, you know, products can change the world. You know, this picture that you see here, it is a GE9X engine, or one of our brand new engines. It's got, you know, a couple hundred additive parts in it. Kind of go through that in some detail coming up here in the next pages. But it really wasn't, you know, pursuing additive that got us so interested, right? It was, how are we going to create a product that changes the landscape, helps humanity, helps move us forward? And that is really, to me, the end game for additive. I like to tell people, you know, I spend a lot of my time today working on the next generation machine technology or the next process technology. But to me, machines are really, you know, a means to an end, so to speak. We have to have those right applications. We have to have the right game-changing technologies that these will go into for it to find its home. I think the other thing that's really interesting as I go around and I talk to folks and we really focus on how do we get additive into their business model, how do we get additive into their applications? You know, we kind of always center around these 5 pillars, you know, machines, materials, process, and then applications and organization. And I would say the top 3, machines, material, process, they're pretty mature, right? I think the machines are certainly today better than they've ever been. The materials are better characterized and they're very usable, right? We're using them in many critical technologies today. The process is really stable. You know, a lot of smart people have been working on it. I already talked about the applications. You know, I think that's still a need that exists out there. And as we push, you know, changing entitlements for things like fuel efficiency is a great example. Additive is going to be a key player in that. But often than not, I actually find that the organization is the single biggest barrier to additive penetrating. So much so, you know, that you often see silos within organizations or the inability to adopt additive because, you know, maybe it is seen as risky, or maybe you have set up your design process with such rigor that folks, you know, design engineers can't talk across subsystems. A great example, I had an automotive customer, and we were digging into how to, you know, really change the game on this particular power plant problem that they had. And we had what we believed to be a really great potential solution. But when it came down to time to implement, the pushback we got is, yeah, well, I'm part of the power plant division. The people, the items that you're talking about integrating into this single component or into this new part or subsystem are in transmission, and some of them are in the body and chassis, and therefore, you know, we can't have those type of collaborations. And I think that's a real shame when those things happen, and just an organization's ability to be able to break itself down to adapt to this changing, you know, design tool is really important and a big barrier. But more often than not, the biggest function is just that the organization doesn't believe, you know. So we like to enter into these conversations with a simple hypothesis. And this is kind of the hypothesis that I want to use today to talk through all of the, you know, many people and groups that have found a way to break through these barriers. And that hypothesis is this: In order to unlock the potential of additive manufacturing, an organization has to believe in production being a reality. I feel like once we get to that point, once the organization and particularly the influencers within that organization can grasp the fact that additive can be real in a production setting, and this goes all the way from aerospace to energy to medical to automotive, etc. We always, I would say nearly 10 times out of 10 find that solution that works and are able to find a really great value proposition for making it into the organization and becoming part of the supply chain. And so what I thought I would do is let's walk through some of those, not only examples, but maybe talk through some of the learnings, the key learnings, and even our own evolution here within GE as users of the technology, and some evolution of others, as well as maybe a sneak peek into where are some of the areas where we're going, and some of the things that we're going to use to enable those next generation of products in the near future. But we'll start here within our four walls here at GE. I think a simple place to start is in our aviation engine division. As the video showed, this is where I got my start. I was an engine designer for many years and really focused on that, and really was fascinated by additive's ability to change the game. But, here are some examples across the top of places in the commercial space where we've really penetrated, and these are ordered, sort of in chronologically, so you can see how it's changing the engine as we know it. All the way back to our GE90, which is a legacy product introduced in the mid '80s, where we went back and we introduced a part that was having some field issues, and in really quick time we're able to come up with a solution and implement it and move it on. The LEAP engine, which like we said, that's one that I know really intimately. I worked many years on that product. It's flying every day with its fuel injectors, 18 or 19 of those, depending on the application, all made by additive. To the 9X, which I alluded to in the picture earlier, has 274 additive parts in it, all the way to our newest GE Catalyst, which we'll show you some details of that. But it's hard to even quantify because we took 855 parts out of the bill of materials for that engine and replaced it with just 12, what I'm going to call superstructures. We'll get into that detail. But I think the key is, none of these are not prototypes. These are production applications. These are products, and they obviously require us to understand the process, to qualify not only the process, the design, the machine, but to go and put it through all of its final paces, and really, we have a saying that our additive parts have to stand up equal or better than the parts that they replace, and that's really important for it to gain hold. Good news is you see that today. I think the industry has certainly gotten there, but it wasn't always that way. Fair enough. So if I walk through some of the applications, I have to start, for me, I always have to start with the fuel injector. Only because, as the video said, this was my fourth child, so to speak. I have one here with me. You always have to have one, I assume, and really was a great pleasure to work on. And the interesting thing about the fuel injector for us was it opened our eyes into what was possible, right? We originally assumed additive was just a way to prototype. We thought that additive was a way to do quick test iterations. But this was the first time where we really recognized that we could do major part consolidation. We could improve the weight. We could improve the cost of a part. We could reduce the inventory by huge amounts. In this case, 95% inventory reduction by using just-in-time manufacturing. But maybe even more importantly for me in my purposes as an engineer at the time was, how do I go squeeze 5 times more durability out of a component? And that was really about designing for the physics, right? Taking additive, taking advantage of the complexity benefit that it gives you and putting it in. But just a reminder, this isn't a prototype part, right? It's out there. It's flying today. We can produce up to about 40,000 of these per year, depending on demand, and is really doing fantastic. I don't remember how many million flight hours it has, but it's quite a few. Really exciting to see it out there in the field. You know, I think another relatively simple part, but was really impactful for us, was this one. It's called it's a lever arm for a door opening system on the 747 nacelle, and not the most complicated part in the world, but it was really interesting in that it was this part that came immediately following the fuel injector, where we just had invested so much time and money in building an organization and sort of building this technology and putting it in our toolbox. And the thesis for spending all of that R&D and really making that big investment was the belief that when we needed to use it again, it essentially would be ready. We didn't need to then go reinvest all of that again for the next part around. And this PDOS bracket was a great example of that. That came sort of in the tail end of the fuel nozzle certification process. We needed something out, you know, relatively quickly to find its way into the field, and we also wanted to take advantage of all the benefits that additive gave us from a weight reduction and even cost reduction, et cetera. And so in this part, you know, in 10 months time, we were able to go from a recognized need to a certified part in the field doing its job. And that was really important for us, because it sort of validated that thesis that I showed earlier, that is, you know, additive is here and it can be a production tool, and really for GE change the way we look at it forever. You know, fast forward now, I would say going into our next new product introduction, which in this case was the GE9X engine that I showed. We knew additive was going to start to evolve and start to change the way it influenced our engines. Both the fuel nozzle and the PDOS lever arm, and there was another part that we had introduced sort of in the same time frame called the T25 sensor, which is a thermocouple sensor housing for an engine application. Were all, you know, they were complicated. They were, you know, they had strict requirements, et cetera. But for the most part, they were still just parts. We were taking, you know, a part out, or a small subset of parts out, and we were replacing it with something of sort of equal fit into the engine application and equal function. But the GE9X, as well as the catalyst that I'll show you here in a minute, really were the first opportunity where we started an engine design program with additive being in the toolbox. And that allowed us to think about how are we going to utilize this technology in a way that is more impactful to the end customer, that is, you know, maybe not just a supply chain play, but a real design play as it changes entitlements for the engine. So for the GE9X, you know, I think this represents for us a shift in thinking. And so, like I say in the title here, it was a transition from components to systems. And in my experience, you know, not only working within the GE ecosystem and sort of in the design realm here, but also working with other customers who are at various spots along their additive journey, this transition from components to systems has been the single most important and impactful transition that I see occur, because I have yet to see anybody go backwards once they transition to system impact. So for the 9X, I have some examples here, right? We have the sensor that I talked about earlier. We have the fuel nozzles, as well as mixers for the combustion system. Those were sort of, you know, evolutions of parts that we've been working on previously, but now you're starting to see the introduction of new features like particle separator. What a particle separator is an originally unimaginable system inside a jet engine that can essentially do high pressure filtration of particles out of the gas stream, and that increases the durability of the engine in a really, really important way. This also represents the first time that we implemented a heat exchanger into the engine application. And I tell you, once we introduced our first heat exchanger into any application, in this case, it was the 9X, that also changed everything. We will never, I can't imagine us ever really not thinking about heat exchange as the primary source of design and manufacturing for really any future applications. It has just proven to be, extremely impactful for us, and I think for everybody who plays with it. The other one, which I really like, is the LPT blades, or the low pressure turbine blades. I have an example of a low pressure turbine blade here. This is actually made using the electron beam process, and it's made out of a titanium aluminide alloy, and extremely lightweight, but especially durable at temperature, and just perfect application for their really, really tough part to make. Even in the most traditional methods, that additive completely changed the game. And I would say, leveraging the really unique capabilities of electron beam, we were able to make that happen. So what does this all mean? These are just parts, but at the end of the day, it helped us achieve a lower fuel consumption, better combustion, which led to lower emissions, lower NOx, a quieter system that allowed us to get to higher pressure ratios, which pushes our fuel burn in a really positive way. So again, starting to change the game for not just components, but how do we design systems around additive? I think there's no better place for that than what I refer to as the holy grail moment, and that is when we were working on this new catalyst engine. So this is a relatively small engine in size compared to the 9X. You can see the propeller there on the left-hand side. But this engine, we got an opportunity to design it from a white sheet of paper. And from that white sheet of paper, we built additive right into the core. And so, it's difficult to even explain the impact that it has on the overall engine system. We took out, like I mentioned, over 855 parts out of the bill of materials. We replaced it with just 12. And although that number is impressive all by itself, it completely changed the entire landscape of how we manufacture our supply chain and how we even service these parts. And I'll show you that in just a slide or two. But I do want to highlight as well, this engine was able to surpass the 25% mark as far as additive penetration into the engine. That's huge, right? If you think about what a single part means in terms of a whole jet engine, it's relatively small from an impact standpoint. But when you sort of cross that threshold of 25% of your parts are additive, I think to me that screams that it has changed the way aviation power plants look forever. And I'm starting to see similar things happen in other industries as well. I want to dig in a little bit into one example part that has become sort of a best practice here, at least at GE, and we try to help others with as well. And that is this concept of superstructures, or really consolidating your components in a smart way, a serviceable way. So this is an example here. This is called I call it the mid-frame. And again, I use this terminology, superstructure, just because it has so many different parts into one. In fact, this particular part was 7 sub-assemblies. So these were assemblies that were, came from all over the world. They were sub-assembled into usually inseparable assemblies, so welded or brazed together. And then those were assembled again into this structure. And when you added all the parts up, so these are, the castings, the forgings, the machine, the seals, lots of fasteners, over 300 individual components, now finally down into a part that we print at one time. Not only were we able to print it with one time, but we don't really talk too much, but increased performance, better durability, really designing for all the things that we talked about earlier. And this is where, in the example that I was giving about automotive, where you really start to blur the lines. In this particular component, there would have been many, dozens of individual design engineers that would have responsibilities for these different components. And to get this done, right, we had to really focus on consolidation across the organization. and bringing a lot of those functions into this multifaceted component. But the trip was well worth it. Huge benefits for us in terms of impact to the engine system. You know, if I take it further, I think from a design perspective, that's sort of understood. I think you can see that relatively easy. But the same thing goes to the whole enterprise. So if I just take the same part as an example, and let me go along the bottom row to begin with, or the subtractive process, I guess I'll call it. You know, it was 300 parts to one. I told you there was a lot of engineers involved. In fact, there was 60 engineers involved in that entire process, from all the individual parts to, you know, the aerodynamicist and the thermal systems engineers and you know, analysts, et cetera, many different people. And I would argue that most of those people were focused on the interfaces, right? The areas where multiple parts came together. Those 300 pieces were spread across over 50 different manufacturing sources with probably just about as many different data systems. And so I can tell you that the consolidating all that data back into one holistic picture of, you know, the parts that we have out in the field was a lot of work and required a lot of effort and a lot of organizational burden. And then finally, when the parts were out in the field, we had to repair those, and we had to break that assembly up into subassemblies so they could go out and be repaired by you know, essentially centers of excellence or shops that were focused on that sort of assembly. And all that changed with the advent of this additive part, right? We went to one part. We only needed now 8 design engineers, because all of those interfaces, all of those bolted joints, all of those seals, everything went away. We're really able to design a more holistic system. We had one manufacturing source, one inspection system, one data system, and finally one repair location. And so the entire enterprise simplified and streamlined around this new manufacturing technique. And you know, that part saved cost by itself, just on a piece part by piece part basis. But then when you think about the impact it had from a cost savings on the enterprise, it outweighed it, you know, probably manyfold, and really, you know, change the way we think about how to even do our value propositions within additive, and something we try to work with others on as well. If I change gears a little bit, you know, throw a little curveball in here, as I'm mostly talking about sort of aerospace and energy applications. You know, this is obviously not one of those. This is an implant that this particular implant we make on our electron beam systems. I actually have some here with me today. So relatively small, a socket joint for a ball and socket there. And you know, the reason I bring this into an aerospace discussion is not to really talk about the implant or the huge effects that it has in medical, which are massive, but to really talk more about where inspiration can come from in additive. So in this case, we had some engineers that were working on this particular application. You can see this trabecular structure I'm showing there on the right-hand side of the display is this really intricate sort of lattice, three-dimensional lattice structure that allows us to you know, promote better bone growth and better adoption into the human body. Where that same design engineer looked at this this structure and recognized, you know what, that can make a pretty good heat exchanger as well, pretty good thermal, you know, specifically a surface cooling application. And that's exactly what they did. So they took the structure, they ran with it. In this case, you know, looking at a power generation application where there was some particular cooling challenges, and we're able to implement this in a way that was really impactful. I have that here on this slide. So imagine a structure similar to the one that I just showed, with all these internal, you know, near surface cavities and cooling systems implemented into a gas turbine shroud. What that allowed them to do was reduce the cooling flow that is utilized in that shroud, which is all parasitic losses to the thermodynamic cycle, increase the temperature, the surface temperature, which the shroud could withstand. And we're able to save essentially 1.5 million in equivalent fuel burn by taking this inspiration from, in this case, like a medical type application, and bringing it into a power application with no impact on cost and actually simplified supply chain. And eventually led to GE, achieving a world record on the efficiency of the entire power plant, which is really, really amazing. And to see additive have such a primary impact is really, really impactful. So I've given some GE applications. Those are easy for me to give, obviously, working on those every day. But I also want to talk about how some others are today using additive, again, outside of prototypes and really out in the field and in a production setting. So the first one that I have an example here is, one with General Atomics. I think they're really forward leaning on how to use additive to change the game for their applications. In this case, this is a picture of what's called the Sky Guardian, and they had a really tough challenge with manufacturing, especially for relatively low volumes, really fast pace. It was some tough aerodynamic challenges, and they were able to utilize additive in collaboration with us to develop a titanium NACA duct. And in just about 6 months time, from, again, white sheet of paper to ready to go in an application, 6 months. Huge part consolidation. But I think the really interesting thing here for me was that in this particular part, because it's relatively low volume run, obviously titanium, lots of fabrication associated with a part such as this, we're able to reduce the part by, the part cost by about 90%. So really massive, cost benefit to the application, and eventually that gets passed along through the organization and even on to the customer. I think everybody knows about the tooling reductions and weight reduction possible by additive, but just another great example of utilizing it in a production type setting, well beyond prototypes to make a difference on a final part application here. Another one, which is I always like, again, being kind of an aviation geek myself, is an old project we did on an old P-51, so 75-year-old fighter plane, and they had a big issue where, as you can imagine, the parts are not available. Right there, those dies have well exceeded their lifetime, and you're not going to get any more castings or stampings made from those. And in this case, there was an exhaust manifold that was particularly problematic, and they were short on the number that they could get a hold of to get this back in the air. And so additive became a great solution for this application. So low volume application, but part consolidation, the whole deal. Also took the opportunity to enhance the flow characteristics of this part and even extend the life. And so, I think these all ring home, I think, for us that are in aerospace every day, all the places where we can use additive. But again, it's got to get out in the field. That's the key difference here. If we go off Earth a little bit, two of my favorites, just two quick favorites, and then we'll move on to a new topic, and that is I love this satellite example where, Optisys had a RF antenna where they were able to consolidate over 100 parts into just one. Huge weight reductions, huge non-reoccurring cost reduction. I think that's one that often gets overlooked. I kind of alluded to it in the earlier discussion around the bracket that we had performed after the fuel nozzle on the GE side. But after we had developed the technology and really crafted it, our ability to then redeploy it and use it in other applications was really efficient. And I think a 75% reduction in NRE is a great example of that. Even within, an entire engine design, we see double-digit savings in NRE as well. And I think it's sort of setting a new entitlement for what it takes to design traditionally complex components. We're getting not only a lot faster, but a lot more efficient from a cost perspective. Again, all because we're using additive as a design tool, not just a manufacturing tool. That's a key difference. Finally, one more on rocket, just sticking with rockets here, you know, this pogo baffle is a great one. You know, these are, you know, lateral vibrations inside of this particular engine application. But, you know, NASA was able to take a problem that would traditionally take 9 months to solve, and in just 9 days, we're able to create a damper for this system, and get it out there and prove it's working, as well as all of the cost savings and weight reductions and all the things we talked about as well. But 9 days, really impressive to get something to that level in that week time frame, and get it out and sort of in the field. So, you know, I talked a lot about various aerospace applications and sort of, you know, some of the things that inspire me every day. These are applications that do so. You know, I also want to think about maybe the applications that can't tolerate that sort of expense. So, you know, maybe this is not the best example, but it's an automotive example that we did with HRE wheels, and you can see those beautiful wheels there made on an RCAM electron beam machine. But I think, you know, as we hear the call within GE, okay, we have done a great job at attacking a lot of the higher complexity, higher dollar value components, let's say, and those have, for a lot of cases, made the transition from traditional fabrications or complex fabrications over to additive. Same thing in our energy business and across many aerospace and energy companies worldwide. But still today, additive has struggled to cross the barrier that would allow it to enter production in something that is as cost sensitive, for example, as automotive, right? But not only automotive, but the parts that are lower in a, you know, $1 per pound or $1 per kilogram basis on an aerospace. And so that's exactly why we went and developed a new technology to add to our marketplace. And so, you know, everything that I showed previously was either laser system, you know, DMLM, that we use mostly for fine features and you know, broad material coverage, or electron beam, like I gave you the example of the low pressure turbine blade, as well as the hip cups as an example. But those are really excel at those hard alloys, those really, you know, fine features. But again, we didn't have anything to solve the need down in the lower part cost range. And so we introduced, or are introducing, our binder jet technology, right, which I have sort of an example of here, to really go compete on against castings head to head. In fact, many cases we're seeing that the binder jet can be cheaper than castings, even without design changes, which is starting to really move the paradigm for, you know, why do you need any other manufacturing technology besides additive pretty soon. And so, you know, this is something that is really starting to come to market as we speak, and we're working with partners on. In fact, you know, behind me here in the shop, a lot of that work is happening out here as they move through that process. But to give you an idea of what we can get down to, so if I take an automotive powertrain, which is one of the most cost-sensitive applications I can really think of, you know, we've done hundreds of studies on the various components. You know, I've kind of got an example of a 4-cylinder exploded here with all of its parts laying out. What you find is until you sort of cross that $ per cc range, which is what the chart in the top right says, you really don't have any content. There really is no content that's going to compete down there at that range and be cost competitive and give you a positive ROI. But binder jet, with its speeds that are, you know, 100 times faster than a single laser, as an example, powder bed machine, you know, today we're already seeing cost numbers of 25 cents per cc, and that's dropping very quickly as we continue to advance the state of the art in that technology. And what you see on that curve, the y-axis represents how many of those components that we included in our study or in our audit from a powertrain perspective are now cheaper to make using, in this case, binder jet additive than they were to make using the traditional methods. And we're just about to cross that threshold of where over half of those components are actually more cost effective to make with additive. You know, and you can imagine, this is for a powertrain application, but you can also imagine in an aerospace application, that means, you know, many of the castings that that are in those applications are already, you know, cost competitive, if not better today. And that's just going to continue to improve as the technology continues to develop. So, you know, I think this is going to be really impactful to have everything from laser to electron beam to binder jet all in one sort of holistic ecosystem that can service the markets we're talking about in a really impactful way. But what does that mean? I mean, you still have to get that out into the field, right? And so this is a picture I like to use is, you know, additive is like this iceberg here. And I think that when you're sort of chasing that fish, like I showed in that first picture, you know, many people assume that it's living up near the top somewhere, but in reality, we find the productivity for additive is down deep. And I think a lot of people that I was sort of talking to before the show here today recognize that. But you know, what does that mean? I think for us, too often I see users stop at, we have a part, great, I can use it for my prototype, I can move on. But just recognizing that there's so much more than that, right? There is building this whole ecosystem of your you know, I guess your engineering organization or your production organization around, you know, the deep knowledge of the microstructure of the mechanical properties of feeding that back into the design and as well as the feedstock and iterating the parameters, et cetera. That's really where we, at least at GE, and where we've seen most of our customers unlock what additive can allow to really influence from a product standpoint. For us, we follow a really sort of strict and standardized approach that has proven itself over and over. All those applications that I shared with you previously followed this same approach, right? It always starts with identifying a great business case and then making sure you've got your materials and your design and your production process, et cetera, and then getting out there into production. And it's just proven time and time again that if you're willing to go deep and you're willing to take the time and investment to build out, you know, the capability and the know-how and the knowledge base, there will be a windfall of applications and of impact to the enterprise that for us were something we couldn't even imagine when we started. And I'm certainly seeing time and time again across many of the customers who choose to really get down there and implement the technology in that way. So I think with that said, you know, I'd love to answer any questions or have any conversations, as well as, you know, stick around for a while after and have some great networking conversations. But to me, I think, you know, I just love this Henry Ford quote, you know, whether you think you can or you think you can't, you're right. And that goes back to that original hypothesis. If you remember, our hypothesis was, in order to unlock the potential of additive, all you have to do is believe it can be a production system. And I think that again, that's a really powerful thought and is proven time and time again. So with that said, thanks everybody for sharing some time with me today. I know everybody's looking forward to conversing and digging deeper, but I'm happy to take any questions or dig deeper into anything that as you would like.
Thanks, Josh. That was awesome. We've been getting a lot of questions in here, a lot of chat going on with everyone. So I'm going to share a couple of these questions with you. I thought that was really great about just that idea that you have to believe in the future. You have to believe in the possibility of this technology. And I think, you know, for GE, so many great examples in so many different industries. And I love the acetabular cup being used in a completely different industry. It's like, who would have thought, right? It's pretty crazy.
Yeah.
So some of these questions, they're getting voted up. So everybody get in the Q&A window, get your questions in there and vote them up and down, and we'll get to as many as we can. So one of the questions is at the top right now is, and for you, I'm sure you think about this on a daily basis. What do you see as the dream application or use of additive manufacturing?
Yeah. So, I mean, for me, like, you know, I'm sort of a gearhead, right? And so when I think about how I really see additive impacting the future of energy production, especially as we move towards, you know, better fuel efficiencies and really leveraging the resources that we have in a better way. You know, anyone that's ever done a design in, especially like energy production or power plants or anything, recognizes they're always up against the wall on temperature. They're always up against the wall on maybe thermal stresses or part stresses, part durability, aerodynamics. I mean, I'm an aerodynamicist by background, so additive to me is wonderful, right? And so what I've seen, and for me, the dream application is really unlocking those. So all these limits that we used to think we had a limit of this on temperature, move that bar, right? By taking a fresh look at, well, how are we actually managing our thermals? Taking a look at how are we using air to our advantage, or where are we taking pressure drops? Where are we? And so for me, the impact into engines, into power generation systems, into the future of, you know, a lot of the clean energy technology that we're working on, that's the holy grail for me, and the stuff that keeps me really excited. And additive is just perfect for that if you're willing to allow yourself to think that way.
That's great. You talked a little bit about the powertrain applications of binder jetting, and just me personally, you know, we've been looking at this continued kind of acceleration, no pun intended, of electric vehicles and how that's changing. I read a report recently that said that E-Day is coming, which is the point at which the traditional powertrain and the electric powertrain are the same amount of money to produce. How does additive impact that, if at all? And is there any application now that you're working on in the electric vehicle space?
Yeah, we're absolutely working on those applications, and that day is coming quickly, right? I think the benefit you have with a new technology like electrification, like you said, is there's not a legacy of foundries and other sort of supply chains already built up. There's not a warehouse full of tooling that is very expensive and is depreciating, and so you got to use it, right? And so in addition, I think if you think about some of the materials that are needed in really advanced applications or electrification applications, where you're talking ultra high conductivities and new cooling rates, things like that, additive has been front and center. So we are seeing so many customers who are combining additive and electrification, and I think that I'd be surprised to see many applications really take off in electrification that don't have additive as central to either development or production.
Yeah, it's a great opportunity to kind of start over, right? You know.
Absolutely.
I always used to think about, I don't know, I might be aging myself here, but you know, that GM seat belt, you know, that was around forever, that was that metal square seat belt. It's like, I'm pretty sure they paid for that die. I'm pretty sure that one hit for sure.
Absolutely.
Okay, so we've got some other questions here. One of them being, moving from prototype to series production, what are some of the key considerations for organizations?
Man, you know, no doubt to shift a whole organization from one method of thinking to another method of thinking is hard, right? And there's certainly investment required to build that up. But I'm going to be honest, I've seen many organizations get great prototypes and get those to production. And I've seen many organizations have great success in prototypes and they die as prototypes. And the single difference I've concluded is the fortitude of the organization to stick with it. Right. We have there's an event we talk about within even GE on the fuel nozzle. You can imagine first additive application ever, at least within our business, that was going to series production on a flight critical component. There were many chances for us to give up and to stop and to turn around. But we have this moment that we sort of all remember that worked on that project where we said, you know what, we got rid of plan B. We used to carry a plan B traditionally manufactured as well as our plan A. There was a day when we said no more plan B, no more plan C, and because it was distracting us, and as long as we had that crutch there, it was something that we always had to divert time and effort to. When we got rid of it and the only option was additive, that was it. We were going to make it happen. right? And I find that the organizations that do that, when they say this is a great application, we're throwing out all the backup plans, they make it happen. And the ones that carry the backup plans almost always fail. That's been my experience.
Yeah, that's great advice. I think that there's an Eminem song that talks about success being the only option. So it'd be a good motto to adopt there too. That's great. Do you think it's different for companies of different sizes? Do you think there's different considerations? When you're a smaller organization and you're adopting additive and you really want to, industrialize it in your operation?
I'll be honest with you, small organizations have been the easiest, right? The big organizations, I talked about this automotive customer that was so siloed, right, to use that terminology, that they couldn't even, somebody from powertrain couldn't talk to somebody from transmission. Those are hard. And so you have to have an advocate at the very top of the organization. And that's why I would get really excited is working with, like people who are attending today, is we can influence those thought leaders, right? And if you can change that mind, if you can show what is possible, and you don't treat it like just a manufacturing technology, but changing the game on what our future products can be, real visionaries grab onto that, and they will move mountains to make it happen. And that's how we've seen additive take hold within our own organization, and I see take hold within others.
Do you think there's a mix between having kind of those big, the BHAGs, the big hairy goals out there in front of you, and the quick wins that you have to show from time to time to keep people motivated?
Absolutely. Yeah, you need quick wins all the time, right? We all do, especially in, recent time, 2020, 2021, there's been no better need for some quick wins, right? But I think the key is, organizations that go in and want the quick win that doesn't prove to be a good business case will turn away from additive because they don't see it as impactful. The ones who bite off a big enough goal that has a good business case, maybe just put some milestones along the way that allow you to get those quick wins and keep up the momentum, but don't force a bad application because it's easy. That will kill it faster than anything.
Yeah, it sounds too like it's similar to when and lean is still big, so I'm no offense to lean. Lean is very important. But when lean was new and you really had to have someone in your organization that was the evangelist, do you feel that's a similar kind of thing for additive? And how many of those do you need?
Absolutely. We absolutely need those. And it doesn't take many. I think it takes the right one, right? Within organizations, I've seen single advocates that were influential enough to drive the whole business. And then I've seen groundswell efforts as well, where, the engineering community comes together and make it happen. So I don't know that there's any right number, but you absolutely have to have it.
A couple more questions from our folks here. Distributed additive manufacturing. Are you seeing growing acceptance? And if so, or if not, what are some of the challenges that we're facing there?
Yeah, absolutely. I think the acceptance is certainly growing. I'll say it's been still slow, in my opinion. The thing that's holding it back is really standards more than anything. If we can all, play to the same rules, and we can all come with the same level of quality.
Great. I think we lost you for a second there. Are you back? There, you're back now.
Okay, good.
It had a little lag and then it caught up. It was super fast. So great. So hopefully, and if anyone has more questions for Josh, he's going to be out at the GE table when we break here. We've got time for just a couple more questions. Got some questions here about AI and machine learning and what type of adoption GE is making with that in some of the current printers and maybe what the plans are in those areas.
Yeah, absolutely. I think this is a huge sort of next frontier for us. It's something we've been working on for quite a long time. You have to get it right. You have to get it right, because if you want to go implement AI, as an example, as a active participant in the process, and if you want it to be an active participant in the process on aerospace parts, it has to work every time, right? And so So it is something that we are certainly continuing to develop and have spent a lot of time and resources on, and are starting to really deploy within our own walls to make sure that it's right. And I think over the next, in the coming years, you're going to see much broader adoption of active AI inside of these systems that are built on databases that are quite strong and very beneficial. Our binder jet system, as an example, has a lot of that in it already, just because of sort of the newness of that system.
That's great. So more to learn, everyone. So stop by and talk to Josh as well. One last question for you here. You talked a little bit about standards, which of course, ASME, we love that, right? We're setting the standard, I think, is underneath our logo there.
Yep.
But what else can we do to get to that next level that we need to get to? What do you feel are some of the maybe shorter term opportunities and longer term potential?
Yeah, I mean, I think there's this sense of community that can also be really important here. I'll give you a great example, right? We work with some customers who choose to collaborate together and combine efforts on things like material property parameter development, et cetera. I think the more we can bring together the community, just like we're doing here today, and start to share those best practices, and even sometimes that data that the company's held so secret, right? There's some benefit we're seeing starting to share that, because they're also receiving, right? And they're expanding their capabilities very, very quickly. And so, even for GE, that's a hard transition, right? But I think we're really seeing it pay off. And so it's something that I would encourage everyone to consider. How do you collaborate more freely with each other to move the whole water level up, and that's something that I think will move us forward quite rapidly.
That's great, and that's what's so important about the community, being able to network with people and have these great conversations. So much innovation from just conversations here and there. I mean, so many great ideas have come through. So thank you so much, Josh, for being here at the VIP experience for the first time here at the AM Industry Summit. And like I said, Josh will be at the GE table right out in the screen where you were before, and you can see him live, and you can talk face to face. And it's the ability to video chat, which is super cool. And I'm going to turn it back over to Janet, our gracious digital sponsor from Link3D, to give a little more detail on the platform and how everything works today.
Super. Thank you so much, Josh and Debbie, for hosting such an amazing presentation. We're super excited that we were a part of making this happen. My name is Janet Carr. I'm the digital transformation representative at Link3D. We are not a digital conferencing company. We are a software company that helps provide solutions to enable the digital thread for the production floor. But today, we're going to talk to you about what to expect next for this digital environment to enable the networking floor. And so once the presentation is over, we will all be thrown into the 5 floors of the event. So I'm just going to share my screen quickly so you can see. So you might have seen this video that was sent over by ASME a couple of yesterday or so. And basically, you'll see on the left-hand side, there are 5 floors. You can click on the floors. Do note that floor 1 and 2, there are designated tables of 6 for each speaker that is participating in the virtual networking platform. So for example, if you wanted to meet Todd Grimm, you can find him on the first floor right here. So you can just double click into his table, turn on your camera and mic, and then you'll be able to start virtually connecting. Do note that there are 2 ways to view the virtual networking experience. You can use the tile view, which will blow up everyone's faces, or it will have a view called back to floor, which you can keep an eye on the floor. There is special features to make your networking experience better on this remote platform. You can control click an icon. So here you can see my icon on table 25. And there's this functionality called get. So you can be like, get Debbie from ASME. And Debbie will then receive a notification saying, oh, you've been invited by Janet to meet her at the table 25. And once Debbie agrees, she will be automatically zapped into my table of 2. So note that there are a table of 2 if you want to have a private conversation, table of 4 if you want to have a smaller group conversation, and then table of 6. If the table is full, you'll have to wait until someone's there. If someone is not turning on their camera and mic, we will most likely remove you from the table to make space for other folks that want to be engaged in conversations. Do note that floor 4, 3, and 5, these are open tables. So if you want to have a private conversation with someone, you can ask them and say, hey, I want to meet us at the penthouse on table 5, and we can have a conversation there. And if you want to learn more about GE Additive, our wonderful host sponsor, you can actually click on the wonderful links here to learn about their APNC positioning paper, webinar, virtual CEC, and some other customer stories as well. Without further ado, we have over here as well is the general chat. So the general chat function, if you want to have a conversation with someone or want to talk about specific topics, that's a great way to get people to want to connect with you. And on top of that, on the chat functionality, you can click in and see all the people that are currently in this platform. And you can reach out to them directly. And most of you, if not all, should have received a welcome message from myself. You'll see, if you haven't seen it, there's a red dot saying that you have not opened the message yet. Feel free to just open it, and then you can connect with them there. We also highly encourage everyone to also set up their profile as well. So on the top right corner, you can click My Profile, and you can add your picture. We recommend the LinkedIn profile picture for the full name. We also recommend you to add your company name so that when people are looking around, they can easily identify you in the chat room. And then your headline, your company name. If you have a book meeting link, feel free to use it. Your LinkedIn URL is a great way to connect. And then your website. And if you have a Sansan virtual business card, feel free to use that as well. All right. Without further ado, Debbie or Laurelyn, do you want to close out on this presentation?
Hold on. Oh, I was muted. Only my husband could find that button. He'd be so happy. Thanks a lot, Janet. Thanks to Link3D for your help today and helping to put this program together. Of course, to GE Additive and to Josh for a wonderful presentation. And we're going to throw you guys out into what we love to do best, which is reconnecting with people. I miss people so much, so this is going to be so great. And we hope that you'll join us tomorrow and Thursday for our AM Industry Summit. If by some strange chance you are not registered for that, please go do so. I don't think you could come to this without doing that, but just in case, go and register for that, and we'll see you there tomorrow. 30 plus hours of brand new content, aerospace, energy. You know the drill. It's going to be awesome. So we'll hope to see you there. So we'll network now.
Thank you very much, Debbie, and thanks everyone for this opportunity. Have a great day and see you on the virtual floor.